Hey folks, Doug Blake with Body Design University. In this video, I want to help you out with possibly an issue you may have seen in chapter 10. It's on page 420. It's the flexibility assessments. And wanted to go over this real quick because some folks will go through this area of the chapter, the muscular training assessments, whiz right past it, not even really pay a whole lot of attention to it. And then others, as I have heard a fair amount of, will look and ask some questions based on what appears to be an apparent discrepancy in some of the numbers when it comes to the joint ranges of motion. So I wanted to do a quick video to help you out with this and make sure that you're not confused. There's really nothing essentially wrong with the material. I guess if I could say anything, I probably would have, if I were ACE, I probably would have included a full complement of all the joints that they speak about in the particular table, which is table 1012. So let me just kind of help you out here. I've had a couple of folks that ask me, I'm looking at the ranges of motion on these photos. Now, again, I'm on page 420, 421. You go ahead and go there, 422. And what I hear is this number on the picture, like figure 1033, just as a for instance, and you pick any of these numbers, I'll go all the way down to where it says hip extension at the bottom of the page. Hip extension is less than 20 degrees, and you look at that and you go, okay, that's fine. So neutral is a horizontal line horizontal to the ground, and then extension of the hip, and you can see movement of the hip right at the pelvis area just below the pelvis, less than 20 degrees of extension. Well, that's all well and good, but then what ACE is telling you is that go into table 1012, and if I look at table 1012 and I go to the hip, okay, average range of motion for healthy adults, and I go to the hip and I come down and I see extension says 10 to 30. Well, the 20 degrees, obviously less than 20 degrees, falls within the 10 to 30 degrees. But what's up? Shouldn't it just say less than 20 degrees? If you think I'm nitpicking, okay, I agree with you. And I'm going to tell you why perhaps it is nitpicking, but why you don't really have to worry a whole lot about the discrepancy in those particular numbers. And here is the reason. It's almost too simple once you see it. When you read on the, and this is why it's important sometimes to actually read through this and step back for a second and just see exactly what they're telling you or the information they're giving you. And it's really just the difference in a couple of words. You may have seen this. Some of you may have already seen this. The difference in the words are active ranges of motion and average ranges of motion. Okay, so I showed my hand. That is the real issue here. What I'm going to tell you is that when you read through this initial paragraph up top of page 420, it basically tells you while figures 1033 through 1035. So here's figure 1033, lower extremity movements and active ranges of motion. 1034 is shoulder joint range of motion. Now I'll get to some of the, on the other side of the coin, the problem with what they did or did not do. And 1035, active range of motion of the thoracic and lumbar spine. So figures 1033, 1035 use the term active range of motion, but they did not put it in figure 1034. So for those of you that are looking at this and want to let the publisher know, I would, because that's what we would consider, those of us that do read critically for textbooks, things like this, that's what I would let them know. That should say shoulder joint active range of motion to be in compliance with the other terminology that's used in the other figures. So that's just one kind of small issue. Am I splitting hairs? Yes, because this is a critically read textbook, and it should have consistency in those. So I just want to make sure that if you're reading this and you're unsure, this is one of those issues that I would definitely throw out at the publisher. So let me get back. While figures 1033, 1035 illustrate normal ranges of motion for healthy adults at each major joint, only a select few muscle groups that commonly appear tight are discussed in this section. Stop. That's one of the reasons why I've had multiple students say, well, they talk about the wrist, pronation, supination, but I don't see any pictures of the wrist or the elbow. And that's the reason why, is although they're telling you in table 10.2 all of the information related to all the major common joints, they're not showing you on these pictures. They're only showing you in these figures ranges of motion for healthy adults at each major joint. Only a few select muscles that commonly appear tight are discussed in the section itself. So they're simply not showing you range of motion of the elbow or the wrist. Okay. Now, again, from my perspective, I look and I go, yeah, you should have put something like that. If you are referencing in the table, you should have at least given some room to show it. So again, because it can cause confusion. So in addition, now listen, now these are figure 1033, figure 1034, figure 1035. Those are active ranges of motion. So those numbers might appear different than table 1012 presents the average range of motion at various joints for healthy adults. Average versus active. This is one of the reasons why, if you're looking through these figures and you're noticing some discrepancies with the figures and the table, that's the reason why. So I'll give you another example. In table 1012, average range of motion for the shoulder, the scapula, flexion is 150 to 180 degrees, extension 50 to 60. Take a look over on figure 1034. So you have flexion and extension. You'll notice from neutral, you have 60 degrees of extension all the way up to 180 degrees of flexion. That's from neutral. Again, 60 degrees extension, 180 for flexion. Extension 50 to 60. Okay, well, there you go. 60 up to 60. That makes sense. So 50 to 60 would be the average range, right? The active or the functional range of the shoulder is described in figure 1034, which is that everything else being equal, everything good, you can easily get to 60 degrees of extension, somewhere around there. But on average, you might be between 50 and 60. Hence the reason why there is this range. Same thing with flexion, 180 degrees of flexion, right? All the way up, but not everybody can do that. So average range of motion, maybe 180 all the way down to 150. I'm not sure why the range is 150 to 180. I've seen people with less than 150, 140, 130, but they're using whatever data sets they have from research studies, and that's fine. Just want to make sure you understand the difference between what the table is telling you. It's the average 150 to 180 versus the sort of the standard kinesiological data on the human shoulder that says you can go to 60 degrees of extension past neutral, right? So backward behind the body. Same thing with horizontal, and I'm on page 421. You'll notice that horizontal adduction and horizontal abduction takes you all the way back. Horizontal extension. If you notice, shoulder range of motion in a transverse plane, you can see the numbers 130, horizontal abduction to 0 degrees, horizontal extension 45 past neutral. Swing on over and let's take a look at shoulder scapula. It will tell you shoulder horizontal adduction of 90 degrees. shoulder horizontal abduction 30 to 40 degrees. This is the one. And if you circle that, you'll go, now, wait a minute. Average range of motion is 90 degrees horizontal adduction. And here it says 130 degrees horizontal adduction. So what gives? Well, apparently the active, right, active ranges of motion should allow a person to go all the way to basically 130 degrees. So past midline, right? 90 and then pass. So that's what this photo here is showing. Um, again, active range of motion. This one is saying the average range of motion. So horizontal adduction. So from neutral to this. Now, again, it could be that the publisher got the numbers wrong. I don't know. But for the most part, if you look at table 1012, you need to accept the number for what it is, unless they come out, unless the publisher, unless ACE comes out and says, whoops, we made a mistake. You have to assume that 90 degrees then versus 130 on this picture, 90 to 130 is the difference between the average range of motion, where the average person from here can only move to 80. Some people can go to 110. Other people can only go to 90. Other people can only go to 60 degrees. And some people can go to 130. So when you average it out, it comes to 90 degrees. A person can move their arm straight out in front of them. The point here is that I want you to read this critically. Make sure that you understand why you're seeing differences between the figures, these pictures that they've given you, and the table. They don't correspond one-to-one information-wise, because one is the active range of motion and the other is the average. Now, again, that's me reading it critically for you. Another example is on page 422, figure 1035, lateral flexion of the thoracic and lumbar spine. Now, remember, this picture is showing you the active range of motion of the combined lateral displacement of the lumbar and thoracic spine combined. Now, we know that the lumbar, the lateral movement of the spinal column, left or right, lateral movement is pretty limited. The movement of the thoracic spine, lateral flexion, left or right, of the thoracic spine, the 12 thoracic vertebrae versus the 5 lumbar vertebrae, is significantly more. And so you get the idea. In total, it's about 35 degrees from standing up straight. Laterally, I can laterally displace my spinal column with all 17 vertebrae, the 12 thoracic and the 5 lumbar, a total of about, what they're telling you is 35 degrees. Now, if you come over to joint movement, thoracic, lumbar, spine, you come down and you'll look your lateral rotation, thoracic rotation, lumbar lateral flexion, thoracic lateral flexion. So lumbar lateral flexion is 20 degrees, okay? And thoracic lateral flexion is anywhere between 20 to 25. So if I add the two of those up, I'm at 40 to 45 degrees of lateral flexion combined. Again, 35 degrees fits within that. So that active flexion displacement of the spine laterally is going to be what they're saying, about 35 degrees. Does that fit within the combined lumbar and thoracic lateral flexion of those two? I guess. The point is that when you're studying or looking at these numbers, don't get confused and go, wait, that says 35, this is 2020. No, they're giving you these averages. That's what table 1012 is giving you. So let me kind of bring this back to full circle around here. Your goal ultimately from a studying perspective is to know the table. Now, understanding what you're looking at here when it comes to the actual pictures and these figures, That's one of the things that they're giving you in Figure 10 to 36 worksheet for conducting flexibility assessments. So keep in mind that if they're going to ask you questions on the exam, it's probably going to come from table 1012, but please keep in mind, and if you want to, from a studying perspective, keep the two data sets separate: average range of motion, which would be table 1012, and active. Active. Sometimes you'll use the term functional range of motion on the other. So your functional range of motion numbers are going to be, in some cases, a little bit different. Remember, you do not have figures or drawings here for the elbow and for the wrist, but they are given to you as far as average ranges of motion, table 1012. And again, I will kind of conclude this with a dose of reality, which is that we generally don't do these type of assessments, which is why ACE will tell you right at the get-go, client and personal trainer may collaborate on whether to assess the flexibility of specific muscle groups. May. Most often not, to be honest with you. Doesn't mean you don't study. It doesn't mean it's not good information. It is. And if there is a discrepancy that you note with a client and they come to you with clear issues related to joint flexibility, then it may be a good idea to actually do kind of before, intermittent, and then sort of final flexibility tests with the issues that they may have. So I hope this was helpful. This video is really designed to do two things. Number one is, again, if there's some inconsistency or clarification that you needed, I'm hoping that you go, oh, well, that makes sense. That makes sense. That's why I was wondering why these numbers are different than these numbers. Please, now, hopefully you can go. That's the first thing. The second is to keep in mind that in the real world, be very careful and be very conservative about doing any type of assessments that are going to involve all these type of measurements. Generally, we use goniometers. Therapists use goniometers to literally measure the exact angles or pretty close. But a personal trainer, it's not recommended. Again, if a client does come to you and then basically says to you, I've had shoulder operation, I've had hip issues, this and that, and I'm trying to increase my flexibility, that's when you collaborate with your client. Maybe it is a good idea. And by the way, the two really important joints that you're going to deal with anyway, the hips, the lumbo hip and pelvic area, and the shoulders, for instance, you've got that in the Thomas test. So go ahead and turn the page over, and you're going to get to a way more important testing scenario, which of course is going to be the Thomas test, the passive straight leg raise. These are actually going to be more in line with what a personal trainer might do in their normal day-to-day training of clients. So again, hoping that this video is helpful. If you got any questions, leave them in the comment box and just let us know how we can be of assistance as well. Have a great week. See ya.